All right, Internet, welcome back. Or should I say, hello again. It's been a while. You may wonder why the Grinch is on screen, and I will explain that in a second. But first and foremost, today we are doing Natas 16 and 17. And these were both difficult ones, new, similar type of attack, but a different variant of it. And today is really all around injections as usual. And the injections are blind SQL injection, and the other one's time-based. So blind SQL injection is, here's a website basically. And when jumping into this problem, let's take a step back. When jumping into this problem and the other, I'm not obvious, but I didn't really know what I was doing because I never really know what I'm doing. So at first I played around with this, and let me refresh the screen so you have, this is what it would look like, right? So you have the basic screen, nothing on it. At first it's going to state, okay, so for security reasons, we're now filtering even more certain characters. This is based off the previous attack that we did. And if we jump into the search bar, type in anything, so WED, you can see basically what we're doing is we're doing what we did on the previous challenges, where we're searching for the text we've input into the search bar in the dictionary text file that's provided in the source code. So if we do that again, we can clear it. And if we jump into the source code, we'll see, as usual, you can skip over the header stuff and then jump right into the actual body. And if we scroll down a bit here, you'll see that what's happening is we're actually doing a regex. So we're actually canceling out a lot of characters. So previously we were able to concatenate certain SQL characters, or not SQL characters, but grep characters. So we could actually utilize this grep here that's being searched on for the pass-through statement. And then we could use some additional characters to kind of add a sequential statement. And last time we leveraged the semicolon here to basically add additional commands inside of the grep, so we could do additional things outside of just searching this text file that's been provided here. But with all that being said, now that we have the reg match, which is these basically symbols here saying that of these symbols, we're not allowed to use any of these due to the fact that they're being filtered out. And that's the additional security function they mentioned here around filtering. So the first thing that I did here is I actually didn't cheat immediately. At first I said, okay, well, what characters are left? And I remember that there was a website that I went to around code injection that showed that. So if I go to Wikipedia here, it shows you there's a section for shell injection. And if we scroll down a bit, we remember actually seeing this table from a previous challenge. And in this table, you can see there's a variety of different commands that you can put in that allow you to basically add sequential commands on top of a pass-through statement. So here they're doing pass-through, but you can do it for other functions as well for PHP. Specifically, like I said, we use semicolon, but if you look through these different options, you can see that the command substitution option is actually not being filtered within the code. So the command substitution is basically going to be the $ and the different parentheses, or parens. And if you go in here, you can see that that's not an option. So that's good. That means that we can leverage that for this command. Once I've done that and looked through that, then I kind of didn't really know what to do next, so I cheated, of course. So if I close this out and jump into the Apache blog, Apache's to the rescue again. He helped us out. And in here, there's a few points that are made. He came to the same conclusion we did, but made some additional steps to actually figure out what could be done next. And before I explain his solution, let's actually talk about what kind of attack we're doing. So a blind SQL injection attack is what's happening here. And this is part of the reason why I've put up the Grinch, because when thinking about a blind SQL injection, and even the next attack that we're going to do for the time-based stuff, it's really, we're just throwing, the way I see it is, let's draw some stuff because we can. The way that I see that we're doing this is we're basically throwing something in a tunnel. So say we have us here, then we have some sort of tunnel, and then we have, the treasure chest of the server that we're trying to get access to. And what's happening is we're basically throwing stuff down this tunnel and listening to what echoes back. And we're hoping that whatever echoes back gives us some indication of what is potentially sitting behind this secured, basically, cave, this server. And whatever comes back, we can actually do some sort of like Sherlock Holmes effects where we can deduce based off of the response what the password could potentially be. And when thinking about that, It reminded me of The Grinch, this specific scene. I'm not going to play the whole thing, but it's a good movie.
Hello!
He's getting his echoes back.
How are you? How are you? How are you?
Oh yeah. Don't want to get my YouTube shut down, so we'll stop there. Anywho, so that's what we're doing here is we're basically passing off something to the server. It's going to give us a response. That response might not be significant because in previous challenges, the response that we received, remember, was basically a character saying that is this character a part of the password, and it would come back stating yes or no, true or false. Now we're going to pass something off and we're not going to get really anything back. So that's why it's blind. We're not getting much of a response back, but even though we're not getting something back, that is something in itself. By not having a response, that is a response. And with that being said, let's jump into Apache's response and his kind of conclusion. And before I actually jump into Apache, so there's 3 different sources I came across. So I came across Apache, which had a good code set that I could use for the script to automate this. There was also another source here for the n0jgithub.io. This individual did a good job just explaining overall what we're doing. And then Johnny Schatz was another answer that actually helped me understand the grep statement even further. Because I'll explain to you that we're actually going to adjust this grep statement to actually get what we want back. Alrighty, so let's look at the code because I want to explain what we're going to do here. So what we're going to do is we're going to figure out what we can inject into this section here to basically guess at what characters are included in the password. And once we've guessed at what characters are in the password, then we can guess the alignment of those characters to get the password and guess until we find the password for Natas 17. And as usual, we have an idea of what the username is because we're on Natas 16, so we're just going to assume that it's Natas 17. And in addition to that, we're going to add some additional items in here. So we're going to guess characters A, B, etc. And that's going to be kind of how this is structured. I'm actually going to show you my notes. And in my notes, there's 2 grep statements here that I kind of wanted to talk you through that made this kind of concept resonate to me better. So first things first, we want to basically ensure that we're going to this file location, because this is the file location that this is where all our passwords sit when we're ever trying to get onto the server. It's going to be etc Natas webpass Natas 17, which is what we're trying to get to today. And then we have our grep statement, and then we're searching for B. So we're going to grep for B in this password folder, and then we have basically an OR statement here, separating the test and the Natas 17. And what we're saying here is basically we're going to grep for B inside of this location. If that's true, then I want you to return nothing. But if that's false, then I want you to return test. Or I actually want you to search for test in the dictionary text file. So let's do these side by side so it makes more sense. Let me zoom this up a bit. And let me kind of explain what we're doing here once more. So we have this grep statement, and this entire grep statement here, which is going to go from here to here, that whole section there, is actually all going to go inside of this segment here. So right inside of this key, because this is an additional grep inside of the original grep that we have, and that's the reason why the $sign and the params that we found on Wikipedia that haven't been actually regetched out here can be used for an additional command that we can include here, which is an additional grep. And that grep is going to be, like I said, for that file on that location where the password sits. So this is the kind of the overall situation that's happening. So we're going to grep for I, and that I is going to have an additional grep, which is here. And that grep is going to grep for B, the character, inside of this password. And if that's true, it's going to return nothing. But if that's false, then we're actually going to do our original grep for grep in case insensitive, I-I, for the word test. And if that's true, then we're going to search for test inside of this dictionary.txt. So with all that being said, I think actually putting this inside of the search bar would be useful to kind of show you what this looks like. So if I just copy and paste this grep command out here into our search field and do a search, you can see nothing's come back. So we know that lowercase b is a part of the password. But if I do this again And let's do 1 instead of B. Do search. 1's a part of it. Maybe I'm messing this up. Let me try it one more time. 2. Aha, 2 is not a part of the password. Let's try 1 again. I think this space kind of messed me up, maybe. 1 is a part of the password. Fair enough. So as you can see, when we input the grep inside of the additional grep, it grepped for that character B and that character 1, and both of those were a part of the password. But when we did 2, it wasn't a part of the password, so it actually searched for test, which gave us back all the words inside of that dictionary.txt, which sits here, that had the term test inside of it. So now that we have an idea of how we can basically figure out the conditional formatting or the conditioning, so the conditioning here is saying basically if you return nothing, so we'll say n for nothing, then I know that this character that we've sent off to you, say that is B, this character is a part of the password, right? And then if it's not a part of the password, then I want you to search some generic term. So we're using test for the time being. And I want you to search that term inside of the text.txt file, and then that's going to return whatever it returns on a consistent basis, which is all the words that have test inside of it. So this is our condition. So if we can take that condition and put it inside of a program, we can run that program consistently, figure out what character is a part of the password, and then once we figure out that, then we can actually kind of order our password. So with that being said, I'm going to take you to the code. So this is the code from Apache. I've moved some stuff around to make it more sense, make more sense to me, so I could explain it to you, hopefully. And let's jump into some of this code to explain it a bit further. So as usual, we have 2 major functions here, right? So the first larger function, and what I can do is I can actually separate this out so it's easier to read. So let's do that, and let's do that. Separate these out a bit more. All right. And so what you have here is you have 2 basically loops, not functions, but for loops. And this first for loop is going to basically figure out which characters are a part of the password. So they're going to basically search all the characters, which is here, and this is all the different ASCII characters and digits. So we have 0 through 9, capital A through Z, and lowercase a through Z. And we're going to search that basically iteratively. So we're going to search over this list. We're going to tag that onto this larger basically query that we're going to input into that search box. And you can see starting from here is the grep command that I explained to you previously. And the grep command here that we're doing is very similar to what we've seen previously, but we're testing doomed instead of test from what we tested last time. So remember, we're basically doing a grep, and the grep's going to be on any character that we pulled from this list that we're looping through. So we'll start with A, then we'll go to B, and then C, and then D, etc. And then we're going to keep replacing this. And then we're going to basically put that inside, and we're going to check this file inside of this location, and we're going to see if that character is inside of it. If it is, then I want you to return nothing. And once you've returned nothing, then I'm actually going to tag that character onto our filtered characters section here. And then if it's false, then I want you to return doomed. And there's an additional if statement in here that's basically stating that if doomed is not in the text, and the r.text is basically reading the page. So if we have our page and we've searched for doomed, then doomed's going to be on the page. So if doomed is on the page, then we know that it's not part of the password. But if doomed is not on the page, here you can see, then we know that it is a part of the password, the character we've searched for. So then we're going to take that character, we're going to append it to the filtered characters like I said last time, and then we're going to print that out. And once we've done all that, and actually let me take a step back and show you what that looks like in Natas 16. So let's actually take this, copy that, and drop it in here. And there's additional stuff we need to change. So we're going to have, so we'll grep for another character. So remember, we knew B was a part of it, so we're going to do grep for B on this, and then we're going to search for doomed. So we'll search that. Nothing came back. So that means that B was a part of the password. But if we do the same thing, probably should have copied and pasted that here, and we do 2, like last time, because we know it's not a part of the password, and we search that, then it's going to bring back doomed. Now remember, the r.text is searching for the stuff on the page. So we have our r.text here, and that's going to search for doomed. And if doomed is on the page, then we know that we should append it to the filtered characters. So once we've done that, we have our list of characters that are a part of the password, but now we need to organize them. And now we're just going to do the same process, but we're going to iterate submitting those characters together. So this is the same kind of concept with the for loop. We know that it's 32 characters, so we're going to do that 32 character range. We're going to filter through that loop. And then after we've filtered through that range in that loop, we're going to actually we're going to get a request, so we're going to send that request again. And then we're going to actually append the character to the password instead of just searching for the character. And we're going to do that on the filtered characters. So we're going to go through all the filtered characters. We're going to tag those together and say, is this letter and this letter a part of the password? Okay, that's good. Don't send anything back. Is this letter, is B a part of it? Then if yes, that's good. So don't return anything. Then we're going to check, okay, is B1 a part of it? If B1's a part of this password and nothing was returned, that's good. Let's keep moving. Is B12 a part of that password? If no, it returns doomed, then we know that that's not the right location for that, because we know all these characters are a part of the password. So with all that being said, I hope that kind of makes sense. It made sense to me after I read through it. And what I'll do here is I'll quickly not run the entire thing for you, but I will run some of it. So let's do 16. And you can see what it's doing now currently at the moment is it's printing. Oh, don't do that. Whatever you do, don't push buttons while the program's running. Okay. So what's happening here, I'll do it on this side. What's happening here is we're pulling in all the different characters that are in the filtered character set. So you can see that these characters here are a part of the filtered set, which goes here. And then these characters that are being populated here are actually the correct order for the password, which is going to be in this section here, because we're basically saying, okay, is 8 a part of it? It is. Okay. Is 8p a part of it? Okay. Then I'm going to tag that to password. Is 8ps a part of it? We're going to tag that. And we're going to continually keep tagging those onto that. And we're going to build out this password over time. And then we'll eventually get to the 32 character set. And you can see if I scroll up here, this is the password, and you can see that's what's being built out at the moment. All right, Internet. So that was not how to spell clear. So that was Natas 16, and now we're going to go to Natas 17. All right, so Natas 17. This one was a tricky one because the last one was tricky because it's a blind SQL. So we send something back, nothing comes back, but that nothing is something useful. But now, if you look at the source code for this one, for the time-based SQL injection, we're not getting anything back similar to what was the situation last time. We're not searching on anything, which is different, but this is a username password situation. And if I go into here, you can remember you could skip over the header piece. And then here we have our database, similar to what we explained last time. So we have a list of usernames and passwords. We have a series of if statements. And in here specifically, what caught my eye initially was the fact that if you look here, you can see that in the previous challenges, we at least had responses that let us know if something existed or didn't exist. But you can see that this is actually all commented out, so there is no response. You're getting nothing back, which is somewhat of an issue. And when thinking through this, I got stumped as usual. So I researched and tried to figure out how other people solved it and what they did. And I found out about a thing called a time-based SQL attack, which is pretty crazy stuff. And let me kind of show you this screen, which is quite useful. But I guess briefly we can actually talk through what it is first. I think I can explain it through an example. So first things first, I'm going to try to explain the theory. So like I said, we have ourself here, and we have our tunnel, our magical server on the other end that we can't reach. We're going to send something off to the server. And we have two conditions that can be met and two responses that we expect to have, because we're going to ask basically the database, does this user exist? We know that Natas 18 is our user, that's what we care about. But in addition to just looking for the username, we're going to ask, does this username exist? So we say username is Natas 18, so we have user and we have a password on our table, right? So we're going to ask, does Natas 18 exist? And, is the character A part of the overall password? If this is met, if this is true, then I want you to sleep for 3 seconds, meaning I want you to take 3 seconds to respond with nothing. So we'll wait 3 seconds. But if this is false and the character A is not a part of the password for Natas 18, then I want you to respond as usual by default immediately. So that's going to be like, 0 second response for us humans, us meatbags. And to show you this, there's a series of articles that I read to kind of learn more about this response and this answer. I think this individual here, the same one, NOJ GitHub, did a really good job explaining how the SQL sleep function works and how it's incorporated into the overall query. This individual here, they did a good job at explaining, I think they did a good job at explaining the sleep function as well. And they also had a simple code base. This is an article I'll explain in a second, but okay, let's jump back to this one here. So in this explanation, you can see there's certain manual commands we can put into the text search or the username field. That's basically a SQL command on top of the username piece, and the same thing applies here. And if we go to the code, we can see that inside of the search that we're doing for the query in the database, the query that we're putting into the username field is going to fit right into here. So we can say that it's going to be, we're going to select from the users where username equals and then our request. And our request is going to be pulled from whatever we input. And we can see that the initial piece of this is going to be username, blah, 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 put whatever else you want to put in there. And if we actually take this part of the query, so we're looking for the username, Natas18, and we're going to do a few other things, and I'll explain that in a second. So let's copy this here, and I'll come back to briefly explain what this says. So there's an if function, right? This in function here. Ignore all the gobbledygook inside of it. So we have an if function. And actually, one second, internet. I think I actually have an opening here. That's the comments. Here we go, if function. This is what I was looking for. So this if function has a few sections. So we have a condition, we have the when true, which is the first piece, and we have when false is the second piece. That's basically saying if this condition is true, then do the first thing. If this condition is false, then do the second thing. And in here, for this solution we're looking at, we're basically saying if the binary for the first character of the password is A, then I want you to sleep for 10 seconds. If not, then I want you to return immediately. That's the true false piece. Same applies here, but it's vice versa. So we're saying if the binary, the first character of the password is letter A, then I want you to return immediately. If not, I want you to sleep. Hence the reason why I was taking, this was coming back so quickly, because A was not a part of the password. So this is the false piece now. So we're saying if the character A is a part of the password in the first character, then I want you to return immediately. If not, I want you to sleep. So if you push enter, you can see that it sleeps for 3 seconds. So that means that it is not a part of the part of the password, because we're actually getting the response on the false section. So we're getting the false piece of sleeping. But then if we do the same thing, and I know, because if I open up my notes, we can see that X, lowercase x, is the first character. So if we go in here and replace the A with an X, and we do that, it comes back immediately. So we know that that is part of the password. So what we're doing here is we're leveraging a time-based SQL injection, like I mentioned previously. This is a great article. Recommend you reading it. It really gives you a breakdown of what it is and what's happening. We're leveraging a function within MySQL, which is a sleep function, and that's basically going to have it sleep if it's false or true. Additionally, we have the if condition, which I talked about, which is basically where you place that sleep function and the condition of the password character you're looking for. So this is definitely a recommended thing to read. Another thing that I found quite useful was actually going to the actual documentation for sleep to understand more about how sleep functions and some of the kind of the stuff behind that. So recommend that. Another thing that I came across for reading through different answers. So if you actually go to this answer, you can see they've commented out at the end with the hashtag. And here they've commented out at the very end of the command with dash dash, which I don't see here, but I know it's there somewhere. Here we go, dash dash here. So you can see it's a dash dash at the end of the comment. And let me kind of explain what I'm talking about because I'm all over the place. So let's go to the code, right? So we've done 16, now we're doing 17. And now that we have a general idea of what we're going to achieve, we're going to basically go through the iteration of what we just shown you. And let's put on some good coloring. All right. So we have Natas 17. We have our potential characters. So these are all the characters that you can guess. Then we're going to skip over the first set of steps that we did previously of basically getting the filtered characters that are in the password and ordering them. We're just going to order them as well inside of the same for loop. So we're going to iterate over 32 characters because we know that's what it is. We're going to try to find that range. And then we're going to basically iterate over all the possible characters we can use. Then we're going to funnel that into this request here. And as we said, we're going to look for Natas 18 in the username table. We're going to say, okay, Natas 18 and the password is the piece we're looking for. And we're going to ask basically, is there a comparison? So a comparison of like binary because we're doing in case sensitive. And then we're going to basically say, is this character J inside of the password here? So is character J inside of this password? If it is, then I want you to sleep for 2 seconds. If not, then just immediately shut down or respond right away. Now, as I said, the other one had a hashtag here at the very end of the command. And this one has a dash dash, as you can see. And I wanted to know what that was and why that was the case, so I played around with this code and messed around with it and kept on running it through my terminal to see what the issues were. Then I ended up actually Googling what the commenting piece at the end of the command was, and I found out this is another useful article from the same website that basically gives you an explanation of why the comment is actually included at the end of an injection. And the reason being is that if you go into the code here, there's additional items at the end of the query. There could be potential items at the end of the query. And what we want to do after that is we will actually want to comment any additional items out. So if I scroll a bit further down here, you can see that in this example, they have an SQL query, right? And they have the value that we're inputting as a username here. And you can see after the username value, there's an additional and after it saying show public equals 1. But we actually don't want the show public equals 1 to actually execute. We want the command to end where we want it to end, which is where the end of our command is. So if we actually add our input value, which is going to be admin, and we add the dash dash at the end of that, that's simply just a comment segment. So anything after the dash dash is going to be a comment. So that's excluded from the execution of the program. So if we add the XX here, it's going to exclude the rest of this as a comment, and it's not going to acknowledge it. It's only going to compute what we want it to compute, which is everything prior to that. And that's exactly why they've added it in their code here, because they want to make sure that any code that sits after what we've input for the username is excluded, and we're not worrying about it. And that's kind of something that was an epiphany to me, and that's why this actually started to make sense. And another interesting thing about this is white space is needed after the dash dash. I read that in the PHP documentation, or SQL documentation. Okay, so as I said, we're going to iterate through this. We're going to get our password. We're going to have it sleep for 2 seconds, and then we're going to get a response. So if I actually run this, it's going to take a decade or two, but we'll let it run for a bit so you can actually see what's happening. And as that's running, I'm going to quickly see if I missed anything. So I used the one website I just closed out, I used their code snippet because it was more useful, at least for me. And let's check our terminal. And we can see that we're starting to get some feedback here. Oh, damn it. Damn you, terminal. It errored out because I messed it up, guys. Sorry about that. So as I said, what's happening here is we have our terminal that's basically going to run through. It's going to give our password here. And what it's doing is it's iterating through. It's figuring out what characters matter to us. Then it's basically appending those characters on here. So we're here, we're saying, okay, is X, so we'll start with J. So is X a part of the password? And it's in the first character. If so, then sleep for 2 seconds. It slept for 2 seconds. Okay. Next one is V. So we're going to say, is V a part of the password? We could see V here. And is it in the second location of the password? If so, then I want you to append that to X that we already have, which is sitting inside of this list here. So we have then X, and then we added V here. Then we looped over it again. We checked, okay, so is K, capital K, a part of it? In the third location, it says yes, so we added it there. And we're just going to continue looping through this loop until we get the final answer, which is going to provide it here. And if we go into our notes, we can see that we're connecting it pretty well here. So we have XK, XVK, LQ, etc. All right, Internet. That was a struggle and a half, man. That was a tough one. But hey, we're learning so much. Internet, I'll see you again later. Maybe not. I don't know. Peace.